So, this is another stats help thing, and this is for the study guide on the one Letterman gave us. This is number 14. So, yeah, damn. Anyways, I'll just read it to you and just point out the main things we should look for and what we should do. So, 10 students in the graduate program were randomly selected. The grade point averages GPAs when entering the program was between 3.5 and 4.0. The students' GPAs when entering the program and their current GPAs were recorded. Given a 90% confidence interval, I'm just bold that. Maybe highlight. Where's highlight? Whatever. Given a 90% interval, use regression analysis to provide below a test whether entering GPA is a useful predictor of current GPA. So regression analysis, also bold that. But I'm trying to find highlight. Oh yeah, right here. I like that. Okay. So what I highlighted was we need to do regression analysis with 90% confidence interval. And I want to just like state whenever you see regression analysis or the confidence interval, you just go straight to your paper and you just write out the equation because it's like the master equation for everything. So I'm gonna just write it up here, number 14. What the hell? Yeah, number 14. Just write it out. B1 equation for confidence interval. Int is B1 plus or minus T radical or T star times times the standard error of B1. In parentheses. Yep. So this is what you always want to write. And like later on, you're going to see that you need to find the T radical, and you can find that by stating the inverse T. I'm going to run out. Let me switch tools. Inverse T. Inverse T selection on the calculator should be on there. Of the confidence interval, which I won't explain sooner or later. Confidence interval, int, comma, your degrees of freedom, df. So we know we want your slope to B1, we want a T radical, and we want a standard error of B1. So we're just going to write out the givens. It's so much easier this way. Everything just goes faster. Alright, just write out the givens. It takes 2 seconds, and everything goes faster. So the givens are going to be right here. So I typed everything out already. What we really want to pay attention is to this. The givens, the B1. How do you highlight that? You want to highlight that. So this is what you want to pay attention to. This is on your piece of paper. This is a B1, and your standard error of B1 is right next to it. And you also want to pay attention to the degrees of freedom, which is right here, 2 degrees of freedom, because you're going to need that. Alright, and yep, I'll just keep on going with the givens. So the B1 is going to be equal to 0.03125. Next is the standard error B1, which equals, I really don't like this pencil, it's getting annoying. Let's see if it's better. 0 point, that's okay. Nah, I like the brush more. Alright, let's undo that. Just for the looks. So B1 equals, oh, that's so much better, I like that. B1 equals 0.03125, and the standard error of B1 should equal to 0.257. Then you're going to need the degrees of freedom. I'll just speed this thing up, which is 2 degrees of freedom, which is already given. So you plug that all into the inverse t. So it's going to be inverse I and v, which should be a second var stat. So press on second var stat, and it's going to be number 4. It should be number 4. So lots of people get confused on confidence interval for this one. They usually say C when they usually like put 90% when they see a 90%. Actually, it's looking for the middle 90%. I can draw it out for you. So when I mean the middle 90%, it's, you see the bell curve right here. That's this line. 90%. You want to see the middle 90%, and since it's a double-sided, there's a 5% on each side. 5%. 5% plus 5% plus 9% is 100. But inverse t goes from here to here. So 5% right here plus 9% is 95%. And that's where you put 95.95. Then you comma degrees of freedom is right here, which is 2. And when you do that, your t radical should equal 1.8595. So I'm write it down like in my Gibbons box, sort of. 1.8595. Alright. So now we have all what we need. We have the B1 in the equation. We have the standard error of B1 in the equation, and we have our t radical. So we just plug that in. So B1 equals 0.03125. I have to do plus or minus t radical, which is 1.859 times your center error of B1, which is 0.527. I really like writing with a thick marker. So your interval, when you do all of this math together, you should get negative 0.45, comma, positive 0.51. And that's your interval for 90%. So what does that mean? What does this negative 0.45 to positive 0.51? That means it crosses 0. Your slope of b of 1 sort of does cross 0, which means crossing 0 means your slope is 0, and when your slope is 0, nothing has changed, right? This is a slope of 0. But when you have a negative, it could be that or when you have that's a positive, but when you have a negative, you could also have that. So what, unsure of what happened, so we wouldn't reject our null hypothesis, which means this is possible. So H null means no change. Alright. That means B1 could be equal to 0. And if B1 is included into this interval, that means there's a possibility that B1 hasn't changed. So to be fair, we have to we fail to reject the null hypothesis because we have 0 included. I mean, we could also tell that from our p-value right here. I just want to show you the math. We could see that from there. And since the p-value is so high, we fail to reject null hypothesis. Always. Anytime the p-value is above 5%, we reject null hypothesis. We fail to reject null hypothesis, sorry. Alright. So back to the question. So in conclusion, because the interval included 0 in the 0 leaf, and the p-value is above the 5%, we fail to reject the null hypothesis. And the null hypothesis means no change. So we fail to reject that there was no change. That means we sort of are unsure whether the program, the graduate program, changed their GPAs. Yeah, so I mean, it's a conclusion that's hard to say, but it's just saying because there was a 0 was included, that means the slope would be 0, and there would be no change in the slope. And practically, we failed to reject the null hypothesis, and we just need more information. All right, I hope that helped. And yeah, I'll try to keep on posting videos. That sort of confused me, my wording. But I'm gonna just try to get better at explaining some stuff. So yeah, you should. That's basically how you do regression analysis and how you do the intervals. And all the time, when you ever see you need to find an interval, use this equation: b1 plus or minus t radical times s, the standard error of b1. Alright, I hope that helps, and I'll see you guys next time.